Okay, here's a very interesting question on calculation of potential. If a charge Q is uniformly spread on a thin non-conducting square plate, the electric potential at its center is found to be V1 equal to 2 volt. Okay, if six such charge plates are joined to make a hollow cube, the potential at the center of the cube is V2 equal to 4 volt. Find potential at one of the vertex of this cube. Okay, so let's first follow the part 1 of the question. So I have a square plate. Fine. The potential at the center of the square plate is what? 2 volt. Charge on this plate is what? Charge on the plate will be Q. It is given Q. Now, if I take a larger plate, okay, let's say something that the length of the plate is L. Now I take a larger plate whose length is 2L. Okay, the length of this plate is 2L. So I can divide this plate into 4 equal parts. Correct? Hmm. Now charge on this plate is Q. So I have got 4 equal parts now. So total charge will now be 4Q. Correct? So what is the potential at the center VC? So one thing we know that VC is proportional to what? Here I have VC1. This is VC1 and this is VC2. So VC is proportional to charge on plate, okay, and inversely proportional to length of the plate, because potential of a point charge is what? KQ by L. So potential due to a point charge is proportional to charge and inversely proportional to distance. So here, because of the charges on the plate, the potential will be proportional to charge on plate, inversely proportional to length L. So here I have charge Q and length L, while here I have charge 4Q and length 2L. So VC1 by VC2 can be written as Q by L divided by 4Q by 2L. So I can say that VC1 by VC2 is equal to 1 by 2, or then I get VC2 is equal to 2 times VC1, and since VC1 is 2 volt, VC2 is 4 volt. Okay, so charge at the center of these 4 plates combined is 4 volt. Now since we have a symmetry, so I could say that this one plate is giving some contribution, the second plate is giving some contribution. So all the 4 plates are giving equal contribution to voltage. All the 4 sections are giving equal contribution to voltage. So VC voltage per section will be how much? Voltage per section will be 4 volt by 4, that is 1 volt. So we can say that because of this one plate, potential over here is 1 volt. Or we could also say that the potential on the corner of the square plate is also 1 volt. Clear? This one section, this one section is creating potential 1 volt. So the corner has potential 1 volt for this plate. Okay. So one part of the question is solved. Now we have, it is given that if 6 such charged plates are joined to make a hollow cube, the potential at the center of the cube is 4 volt. So now I have a cube of 6 sides. A cube has 6 sides. Sorry, 6 faces. Okay, 6 faces. So I just take one plate. I take only one face of length L. Then at length L by 2. This length is L by 2 and this is the length L. So potential at the center of the plate is given to be 4 volt for a cube. But a cube has 6 plates. Okay. So potential due to one plate will be how much? Sorry, 4 by 6. That is how much? 2 by 3 volt. So in front of a square plate near its center, the potential is 2 by 3 volt. Okay. Now what would happen if I take a larger plate? Okay. Now I take a larger plate of length 2L. In that case, what would happen? For the smaller plate of charge Q, at distance L by 2, potential is 2 by 3 volt. Okay, length of the plate is L and distance of this point from the plate is L by 2. So now I take a point L distance away. Okay, here I have L, here I have L by 2. So if I have 2L over here, I have L over here. Right, then potential over here will be what? It is again very easy. So let's call it V1. So V1 divided by 2 by 3. This potential by this potential should be equal to charge on this plate divided by 2L. So charge on this plate will be how much? 4 times this charge. So 4Q divided by 2L divided by Q divided by L. Q divided by L. So V1 by 2 by 3 equal to 2, or V1 equal to 4 by 3 volt. Okay. So for this large square plate, potential is 4 by 3 volt. Now again coming back, I can divide the plate into 4 equal sections. Okay. So this plate has charge Q. Each of the plates has charge. 4 sections have charge Q. So because of this single section, what is the potential over here? Because of single section, I can say that at distance L, the potential here will be V1 by 4. Okay. The 4 sections together are creating potential V1 equal to 4 by 3 volt. So a single section will create potential how much? V1 by 4, that is 1 by 3 volt. Now we can solve the question. So the question says find potential at one of the vertex of this cube. So we have a cube. So let's name this cube as A, B, C, D, E, F, G, H. Okay. Now let's say I want to find the potential at this corner. I want to find the potential at corner F. Okay. How would I do that? So first of all, because of this plate, potential on the corner of the plate is how much? We just calculated. Potential on the corner of the plate is 1 volt. Okay. This is a plate of side L. Okay. Cube of side L. So potential over here is Vf will be 1 volt due to this plate. Similarly, due to this plate also I should get 1 volt, and due to the plate in the back side also I should get 1 volt. So I should get 1 into 3 plus. Now what about this plate over here? So L distance away from the corner of this plate, we just calculated the voltage. For this plate, L distance away, the potential will be 1 by 3. So I have plus 1 by 3. So for this plate, potential is 1 by 3. For this plate also similarly, the point F is L distance away from the corner. So this plate will also create 1 by 3 volt. Similarly, the base plate. Okay, this plate is also having this point L distance away from the corner. So this will also create 1 by 3. So again we get 3 times. So my net potential Vf will be 4 volt.